Okay, so let's go ahead and start with our final video. I wanted to include problem 13 on the previous video, but the screencasting software cut me off. So we'll continue with 13 here. So we have 0.3 times 4 raised to the 0.2x power is equal to 0.2. Okay, so again, we have an exponential equation that we are trying to solve. My goal here to start with is I want to isolate the exponential function on the left-hand side. So to do that, I can divide both sides by 0.3. And then if I want to make the math like as easy as possible, 0.2 divided by 0.3, if I multiply the numerator and denominator of the right-hand side by 10, that gives me 2/3. And that's, I think, makes the equation a little bit easier to deal with. Okay, so I want to get x out of the exponent here to solve, so I'm going to take the natural log of both sides. And then I can take the exponent and pull it out front as a factor. So we get 0.2x times the natural log of 4 equal to the natural log of 2/3. And then I can divide both sides by 0.2 times the natural log of 4. Okay, and that is going to be our solution for x. Okay, so pretty easy, straightforward problem there. Again, you want to isolate the exponential function. Okay, let's move back to problem number 14, solving a log equation. Okay, so again, solving a log equation, first thing we have to do is to check the domain, and the domain for both log expressions here is x is greater than 0. Okay, so we're going to check our final solution against that domain. Now, when we look at this log equation here, this exponent, we can pull out front of the other log as a factor. So when we do that, we're going to get the log base 2 of x times the log base 2 of x is equal to 4. Which makes the log base 2 of x quantity squared on the left-hand side equal 4. Then we can take the square root of both sides. So the left-hand side, that's going to become like the absolute value of the log base 2 of x is equal to 2, which means that the log base 2 of x is equal to plus or minus 2. Okay, so let's go ahead and solve these two equations individually. So we get the log base 2 of x is equal to 2, or the log base 2 of x is negative 2. So if we want to solve those two log equations, we can rewrite those log equations in exponential form. So the log base 2 is equivalent to the exponent base 2, the power is 2, and that's equal to x, which means x is equal to 4. And then when we solve the other one, we get 2 raised to the negative 2 power is equal to x, which makes x equal to 1/4. And since both of those solutions there are bigger than 0, both of those solutions are legitimate solutions for us. Okay, on to number 15. So we've got 3 more examples to do. So for 15, we have the log base 2 of 3x plus 2 minus the log base 4 of x is equal to 3. And no, that's not a typo. That's correct. I want those two log bases different. Okay, so step number 1 for us, again, when solving a log equation is we're going to take the domain of each log function separately. So the domain for the first log is x needs to be greater than negative 2/3. Domain of the second log is x is bigger than 0. X is bigger than 0 is the more restrictive of the two. Okay, So with 15, we have multiple log expressions set equal to a number. We want to take the logs on the left-hand side and combine them into a single log. Well, the problem that we have is the two log bases are not the same. And for me to combine into a single log, I need to make both log bases the same. So typically what we do with an equation like this is we're going to rewrite the larger log base using the change of base formula in terms of the smaller log base. So I'm going to rewrite the log base 4 in terms of log base 2. Okay, so to do that, we're going to take the log base 2 of our original argument x divided by the log base 2 of my original base 4. And we know that the log base 2 of 4 is equal to 2. So that's good news for us. The next thing I'm going to do is I don't want to have this fraction in this problem. So I'm going to multiply both sides of the equation here by 2. Okay, so when I do that, that's going to give me 2 times the log base 2 of 3x plus 2 minus the log base 2 of x is equal to 3 times 2, which is 6. And then I'm going to go ahead and use my log properties now to combine the left-hand side into a single log. So when I do that, I'm going to get the log base 2 of 3x plus 2 squared over x is equal to 6. And then now that I have the left-hand side in terms of a single log, I can use my log properties to rewrite that log in exponential form. So that's 2 to the 6th power is equal to 3x plus 2 squared over x. And then I'm going to solve this equation here for x. So I'm going to go ahead and multiply both sides by x, and then I'm going to FOIL out the left-hand side. So 3x plus 2 squared makes 9x squared plus 12x plus 4. And that's going to be equal to 64x on the right-hand side. And then we're going to go ahead and move all the terms to one side. So we get 9x squared minus 52x plus 4 is equal to 0. So should be pretty clear that that is not factorable. Like there's not two numbers that multiply to give 36 and add to give negative 52. So we're going to use the quadratic formula here. So x is going to be equal to 52 plus or minus negative 52 squared minus 4 times a, which is 9, times c, which is 4, all over 2 times a, which is 9. So this winds up becoming 52 plus or minus rad 2560 all over 18, which is 52 plus or minus rad 2560 simplifies to 16 rad 10 over 18. And then 52, 16, and 18 are all divisible by 2. So we get x is equal to 26 plus or minus 8 rad 10 over 9. Okay, now should be pretty clear, like when we check our answer, our solution x needs to be bigger than 0. Well, 26 plus 8 rad 10 is definitely bigger than 0. 26 minus 8 rad 10 is also going to be bigger than 0. So when we take that and divide it by 9, that's going to work as a solution as well. Okay, so we have two solutions there for x. Okay, let's move on to 16. So for 16, we have 2 times the log base 2 of x squared minus the log base 2 of x raised to the 17th power plus 8 is equal to 0. Okay, and we know that our domain for this, for both of these logs, has to be x is bigger than 0. Okay. Now, when I look at 16, this is like saying 2 times the log base 2 of x squared minus, when I look at that middle log, that exponent of 17 I can pull out front as a factor. So that's minus 17 times the log base 2 of x plus 8 is equal to 0. You guys remember back in the previous video, we did some examples of solving exponential equations that are in a quadratic form. Well, this is an example of solving a log equation that is in a quadratic form. Because if we let u equal the log base 2 of x and do a u substitution here, we can rewrite this log equation as 2u squared minus 17u plus 8 is equal to 0. Okay, and this is an equation that is factorable for us. It factors to 2u minus 1 times u minus 8. So our solutions here are u is equal to 1/2 and u is equal to 8. But we're not solving the equation for u, we're solving it for x. So we're going to go back and replace u with the log base 2 of x. So the log base 2 of x is equal to 1/2, or the log base 2 of x is equal to 8, which means our solutions here are x is equal to 2 to the 1/2 power is rad 2, and our other solution is x is equal to 2 to the 8th power, which is 256. Okay, and both those solutions are bigger than 0, so those solutions are legitimate solutions for us. Okay, last example, number 17, and I'm trying to do like a lot of examples. I think that this section is the most difficult one in chapter 7 and the one that we're going to spend the most time looking at. So we're back to an exponential equation for number 17. We have e to the x power minus e to the negative x power divided by 2 is equal to negative 2. Okay, so let's go ahead and get rid of the fraction here to start with. So that's like saying e to the x power minus e to the negative x power. That's equivalent to 1 over e raised to the x power. And then if I multiply both sides of the equation by 2, we get that equal to negative 4. Okay, so we've gotten rid of the fraction. However, we've introduced a new fraction here. So if I want to get rid of this fraction as well, I can go ahead and multiply both sides of the equation by e raised to the x power. Okay, so when I distribute e to the x power across all of these terms, we get e to the 2x power minus e to the x power times 1 over e to the x power is 1. And that's equal to negative 4 times e raised to the x power. Okay, so if I move everything over to one side, e to the 2x power is like saying e to the x power quantity squared plus 4 times e to the x power minus 1 is equal to 0. And this should look super familiar to you. Again, we have an exponential equation here, but it's written in a quadratic form. So here we can let u equal e raised to the x power. Okay, so when I do that, we get u squared plus 4u minus 1 is equal to 0. So that is a quadratic equation. However, this quadratic equation here is not factorable. Okay, so we're going to have to use the quadratic formula for this. So u is going to be equal to negative b, that's negative 4, plus or minus b squared, so 4 squared is 16, minus 4 times a, which is 1, times c, which is negative 1, all over 2 times a, which is 1. Okay, so that makes u equal to negative 4 plus or minus. The expression underneath the radical becomes 16 plus 4, which is rad 20. Rad 20 is 2 rad 5. all over 2. And then we can simplify dividing the numerator and denominator by 2. So this is going to wind up becoming negative 2 plus or minus rad 5. But again, we're not done solving this, because we're not solving this equation for u, we are solving for x. So we're going to replace u with e raised to the x power. And there are two solutions for e to the x power. The first one is negative 2 plus rad 5. The second one is negative 2 minus rad 5. Well, if we want to solve for x, like I want to get x out of the exponent. So you can think of this two ways. You can apply like natural log to both sides. Or if you want to rewrite this exponential equation in log form, either way, whenever you do that, you're going to get x equal to the natural log of negative 2 plus rad 5. And for the equation on the right, we get x equal to the natural log of negative 2 minus rad 5. Okay, the last thing we have to check, because we've introduced a log into this equation, is are these two arguments positive? And the one on the left definitely is, because rad 5 is larger than 2. So you're going to be taking the natural log of something that's positive. But for our log expression on the right, the argument of that log is going to be negative, so that solution gets thrown out for us. Okay, so that is your lesson on 7.4. I hope to be back in class at some point this coming week. I am going to go pick up some tests today. I could conceivably be back at school on Monday, but it could be as long as the following Monday. It depends on when I have a negative test. Okay, so I'll try to keep you guys posted of my status, and hopefully you all are doing well. So hopefully I'll be able to see you guys soon. Take care.